These are all of the different kinds. So we have a parabola, which we have already seen before. We have a circle, an ellipse, and a hyperbola. Not a hyperbole, but a hyperbola, an A on the end. This is just all of the different ways that a plane can intersect a cone. So if you look at the fill in the blanks, so for a plane that is perpendicular, which means it forms a 90-degree angle to the axis of the cone, which one of those would be produced?
Circle.
No, not a circle. That would be parallel. A hyperbola. Perfect. Because it's perpendicular. Hyperbola. For a plane that is not perpendicular, or it's not parallel either, so it just comes in at an angle, we have two different kinds. So which one's not parallel or perpendicular? Parabola. Either an ellipse, I'm going to write that one first, ellipse, or a parabola. And then a curve that is produced by a plane intersecting at I would say parallel, I don't even really know that word, would be a circle. Just like the way that it intersects. So parallel, perpendicular, or just intersecting. Just like where they intersect, so different points. Yeah. No, that's okay. So then below that, those are all of the standard forms of the different kinds. We're gonna take a day and do each one separately. Like, so every day will be a separate one. But today we're gonna kind of know how to decide which one is which and how to identify which conic section it is. Okay, so we have a circle. A circle is a closed plane consisting of all points at an equal distance. That's okay. An equal distance from some fixed point. We call this fixed point the center. So basically, if you're drawing a line from the center to the outside, it's always going to be an equal distance. So we call that the radius. An ellipse is a closed plane consisting of all points for which the sum of the distances between a point on a curve and two fixed points is the same. We call that a foci. Foci.
Wait, so
basically the sum, so if you add these two together, no matter where you draw them, so if I drew them here, or here, or here, or here, or here, they would always be the same. Like if you added those two distances together, they would always be the same. A parabola is a plane curve consisting of all points equidistant or equal distance from a given point. We call that the focus. And a given fixed line, we call that, this is just vocab, and like I said, we're going to talk about this more in detail. This is just kind of to refer back to once we learn it in more detail in the next couple days, you'll go back and refer to this. But these are just kind of notes that we have to take first. And then we have a hyperbola. That is a plane curve consisting of all points such that the difference. So for an ellipse, it was the sum. For a hyperbola, that's not how you spell difference right there. Difference. No, it's not. Is that how you spell difference? Yes, that is. Between, sorry, spring break, y'all. Okay. Between the distances from any point, two fixed points are called the foci. It's the same for all points. So, like we talked about in the ellipse, if I were to find the differences between those two, it would be the same if I found the differences between here, or here, or here, or here. It would all be the same. All right, so the general form of a conic section looks like this. You won't have to memorize this or anything. That's just what they all look like. So you have an x squared, you have a y squared, you have an xy, you have an x, you have a y, and you have a constant. So you have all of those things. Then, and b is always equal to 0. So you'll never have this term right here. You'll never have an x and a y together. Because there are no conic sections that have x, y together.
Why do they have that?
Just to say that b equals 0. It's like the formal way to say it. So based on just looking at the equation, if a and c are the same number, so if, let's say that it was 1x squared plus 1y squared, then that would be considered a circle. So if a and c are the same value. And they have to have the same signs too. So they have to both be positive or they have to both be negative. Okay? So they must have the same value, same sign. You may want to write that out to the side. Same value and the same sign. They must be the exact same number. And I'm looking at my x squared term and my y squared term. If a and c have different signs, so like one is positive and one is negative, then that would be considered a hyperbola. They can be different numbers, but they must have different signs. And a good way to test that is if I multiply a times c and I get a negative number, so if a times c is less than 0, then that tells me it's a hyperbola. Then for the next one, a and c have the same sign but different numbers.
Wait, so for the second one, they have to be the same numbers?
No, they can have different numbers, different signs.
It's like it can be a square.
They can be same or different numbers for the second one.
So, but for the third one, it has to be different numbers.
Yeah, for the third one, it has to be different numbers because if it were the same numbers, it would be a circle.
But, so this only leaves this one to be the same numbers if this one's different numbers, right?
It can be same or different numbers, but if they have different signs, it's automatically a hyperbola. Okay, and we'll see some
The next one
examples.
can be a hyperbola.
Okay.
So the third one, they have the same sign, but they have to be different numbers to make it an ellipse. If they had the same sign, if they had the same number, like if they had the same number, then it would be a circle. So same number, same sign is circle. Same sign, different number is an ellipse. And then if you only have, so for this it would be a times c is greater than 0. For the last one, if you don't have an x squared or you don't have a y squared, like you just have one of the two, so either just x squared or y squared, then we would consider that a parabola. And we're used to looking at parabolas because we've done a whole section on those. So if you just have an x squared, or now we're going to learn about y squared parabolas, they're just facing the side, then that would be a parabola, meaning like you don't have one or the other. So this would be if a times c equals 0. All right, so we're going to look at 1 through 4, and we are going to determine whether what type of conic section it is. And then we're actually going to complete the square and get the formula into standard form. So look at number 1. I'm going to look at my a and my c term, which would be this number here, which we would call that a 1. And my c term would be which one? The negative 4. So I have 1 and I have negative 4. So which one of the 4 categories would that fit in? Are they the same number? No, they're not the same number. Are they the same sign? No, so they're different number and a different sign, so that would make it a what? A hyperbola. Perfect. So I'm going to write hyperbola at the top. And now I'm going to actually put it into standard form. So if you flip back to the page before last where it has all of the standard form equations, just flip back really quickly. I'm going to make this equation right here match the one that looks like the hyperbola. Okay, so it's going to have some parentheses, it's going to have a fraction, and then it's going to all be equal to 1. So I'm going to take you through this step by step. And we'll continue to do this throughout the sections. Like we'll take each section and do it again. So I'm teaching you kind of like the hardest part first so that it'll take you a little bit of time to let it sink in. And I'm not teaching it, that's why it's 9.6, but I'm doing it first so that we'll get practice with it with every section instead of teaching it like the day before the review and then you being confused. Yes? All right, so when you have an x squared and a y squared and you complete the square, so I'm going to put complete the square out to the side because that's how you get it into standard form. Oops, complete the square. All you're doing is you're doing it twice. Okay, you're doing it for x squared and then you're doing it for y squared. So I'm going to isolate all of the x's together and then I'm going to isolate all of the y's together. So I'm just going to rewrite this equation, putting x's first and then putting y's first, okay? No, this is for all of it. This is for everything. So this works for all 4 examples. So I'm going to say x squared and then here is a plus 4x. Then I'm going to put the y's together. So minus 4y squared minus 8y, and then I'm going to move the constant over to the right. Equals negative 16. So first step is put your x's together, put your y's together, move constant to the right. If you want to write that down maybe to the side, then you can.
Are we going to do all of these examples?
Yeah. And so then the next step, so you put your x's together. So I'm going to put a little box around my x's. I put those together. I put my y's together, and then I moved the constant over to the right. That's your first step. So now I'm going to do completing the square for the x's. And I'm going to do completing the square for the y's. And then I'm going to add all the other stuff to the right. Okay, so if I'm just looking at the x's, first step when you complete the square is you pull out the greatest common factor, but there is not one because my a value is already 1. So I would rewrite this as x squared plus 4x plus blank.
So you couldn't take out x?
No, because I'm completing the square. So when I say pulling out greatest common factor, I basically mean like taking out whatever a value. But since it's already 1, like I want my a value to be 1.
Okay.
Then I'm going to do it for the y's. And so what can I pull out of the y's? Since my a value is negative 4, I'm going to take out a negative 4. Then this becomes y squared plus 2y plus blank equals negative 16 plus blank plus blank. So I'm adding those 2 blanks to the right. So I'm adding this one right here, and I'm adding this one right here. Okay, so this is the second number, and then this is the first number. Maybe kind of color code it. Okay, so let's not even look at the right. Let's just look at this. My middle term is 4. My middle term is 4. I half it. So b over 2 becomes what?
4.
B over 2 becomes 2, and then b over 2 squared becomes 4. So I'm going to add 4 to each side. So I'm going to put a 4 here. So I put a 4 here, and I put a 4 here. That's my first blank. Now I'm going to look at the y squareds. So same thing. I look at this middle term, which is 2. B over 2 is 1. B over 2 squared is what? 1. So I put a 1 here. Here's where it gets a little, not tricky, but you just have to remember, I pulled out a negative 4 right here. So I'm going to multiply negative 4 times 1, and that's what goes over here. Okay? So whatever goes in the blank on the right is your greatest common factor times this. That's just a little shortcut. Something that sometimes gets forgotten. So you might want to put a little star by that and make a note to yourself that you multiply whatever you pulled out in the front by the number that goes in the blank. And that happens a lot in this unit, so I don't want you to make that mistake. Next up is I'm going to factor. So if I factor this right here, it becomes what? X plus 2 squared minus 4. I'm going to factor this parenthesis. Becomes what?
Y minus 1.
Y plus 1, because it's plus right here. Plus 1 squared equals, then I add all this stuff over here. Negative 16 plus 4 minus 4 just becomes negative 16. All right, so then I'm looking at the standard form, the equations on my sheet from before, and it looks like there's a fraction under the x squareds, a fraction under the y squareds, and it's all equal to what?
1.
Equal to 1. So essentially what I want to do is I want to make this right side equal to 1. So what would I need to divide it by? Negative 16. So I'm going to divide everything by negative 16. I'm going to divide everything by negative 16.
Aren't A and B different?
Yeah, that's okay. So my standard form would be, this doesn't, this first term, when I divide by negative 16, nothing happens to it. So I leave it as x plus 2 squared over negative 16. And then the negative 4 and the negative 16, what happens to that?
1.
It just becomes over 4. So this cancels and then there's a 4 left. So plus y plus 1 squared over 4 equals 1. So now that was a lot of steps, but we're going to have a lot of practice, and we're going to see this in every single section leading up to the test. So we learn it today, but we're going to keep doing it over and over and over and over. So for number 2, if I look at my a and my c values, I have 3x squared plus 3y squared. A and c are the same value, same sign, so it is a circle. So now I want you to complete the square and try to get your equation to look just like this circle one.
There's no room in the,
And so this should be a 10, because I think there were some exclamation points. So I want to put my x squareds together, my y squareds together, but before we even start, so I have, I think it's, the bells are off, because it's daylight savings time. Okay, I want to move all of this over to the left side. So I have 2x squared. Because it's a negative 2 on the right, then I move it to the left, it becomes a positive 2x squared. Minus 8x plus 5y squared plus 10y equals 37. So put it in this form first before you decide what type of conic it is, because on the right side it's negative. So I would think, oh, they have different signs. But then when I put them on the same side of the equation, they're the same sign. So that's going to end up changing what type of conic you think it is. So my a and c values are what two numbers? What is my a value? 2. And what is my c value? Plus 5, because it's the number that is in front of the y squared. So a is the number in front of your x squared, and then c is the number in front of your y squared. Are these numbers, do they have the same sign?
It's an ellipse.
It's an ellipse. How come?
They have different numbers.
Different numbers, but same sign. So I would say that it is an ellipse. Okay, now that we have that, I want you to complete the square. So I want you to put that into standard form. It looks just like a hyperbola, except now the difference between the two is that we had a minus sign in between on example number 1. Now we'll just have a plus sign in between, but it's still equal to 1. So try completing the square for that. So for number 3, you should get x plus 4. Nope, that's wrong. That was number 5. You should get x minus 2 squared over 25 plus y plus 1 squared over 10 equals 1. So that's for number 3. Are we good with that? This is 25. Okay, if we look at number 4, and so it's already kind of set up for us. The y's are in different places, but everything is on the left side. So I'm going to go ahead and look at A and C. Do I have an x squared value? No, I do not. So since I don't have an x squared value, I only have a y squared. That would mean that this is a what? A parabola. So when you're doing a completing the square for a parabola, it's actually easier because you don't have to do it for x and y. You only have to do it for one of the two. So I'm only going to have to do it for the y. I won't have to do it for the x because there is no x squared. So I'm going to put this in the correct order. So I'm going to write this as 5y squared minus 10y. And I'm going to go ahead and move the x to the other side because it's kind of just in the way. So since I'm not doing anything with it, I'm not completing the square with it, I'm going to move the 9x to the right and just go ahead and get it out of the way. Because if you go back and look at your equations, it's already on the opposite side anyway. So if you look at the standard form of a parabola, your x is on one side and your y is on the other side. So equals 9x plus 14. Then I'm going to make my a value 1, so I'm going to pull out what? A 5. Y squared minus 2y plus blank equals 9x plus 14 plus blank.
Wait. Why did you take the 9x?
Because I'm not completing the square with the x, so I just moved the 9x over.
There's just one.
Yeah, if it's just one term. If I had an x squared, I would leave it on the left, and then I would complete the square with it. But I only have a y squared, so I'm just going to move the x over.
So there's only going to be like one blank on the other side?
Uh-huh, because I'm only completing the square one time. So I take half of b, which would be -1, and then I square it. So what goes in the blank? 1. Then I take 5 times 1, and I put what in the second blank? 5. Good. So remember to multiply. Then I'm going to factor the stuff in parentheses. So I would have 5y minus 1 squared equals 9x plus 19. And if I look at the standard form, so if you go back, and I'm not going to be too picky about this right now just because we haven't learned about parabolas completely, but if you look at the parabola, it looks like if I were looking at the standard form, it would be x minus h equals your a value and then y minus k squared. So what could I do to this equation to have the number in front of x be 1? Does that make sense? Like, could I pull anything out?
No, you can divide by 1.
Can divide by 1.
Well, you can't do anything.
So for now, like if this were on your homework, I would say you could leave it like this. But one step further, and we'll do this the next time, is if I pulled out a 9, x plus, and so then I have 5y minus 1 squared equals 9x plus 19 over 9. No, that one wouldn't be squared. Then I divide by 9 because I want to get this 9 over here to the other side. My final answer would be 5 over 9, y minus 1 squared equals x plus 19 over 9. So I just I want my equation to match whatever the general equation is. So refer back to those and try to match those with it. But the hardest part of this section is completing the square. So if you can do that, then I'm not too concerned about getting it into the exact form, as long as you can complete the square, because we're going to get more practice with that.
So are those two equations just different